Hi future doctors, welcome to the next class. In this class, we'll see excess pressure inside the liquid drop and soap bubble. So already we said this liquid drop or soap bubble is forming because of surface tension. So now because of variation of pressure, it is going to be broken. How it is going to be broken? What is the pressure? So I am doing here for liquid drop. So liquid drop means inside liquid will be there. So outside air will be there. So with air only one surface is in touch. If you are taking soap bubble, two surfaces in touch with air. Inside air will be there, outside air will be there. That is the small difference you have to observe. First we are doing for liquid drop. Next we will apply for soap bubble. So this liquid drop is forming because of surface tension. For small amount of volume of liquid, it is going to acquire only spherical shape already we discussed. So why it won't gain triangle, rectangle or any other shape cylindrical means it is having lesser surface area and smaller volume. So because of surface tension. Now on these two forces are going to act. One is due to pressure, another one is due to surface tension. So what is the pressure acting on this? F by so force equal to pressure into area. After going to the certain stage, it is going to get equilibrium condition. So force is equal to pressure into what is the area of this? What is the area of this means if it is going to be having r radius, area of this part is going to be pi r square. Next, what is the force due to surface tension? Force due to surface tension is surface tension into length. Now, what is the length of this? What is the length of this means 2 pi r p into 2 pi r. If you equate these two, p into pi r square equal to t into 2 pi capital R because we have taken capital R here. Next, pi will be cancelled, 1 r will be cancelled. Then p is equal to, we have to calculate p. So p is equal to 2t by capital R. This is the excess pressure. So what is the internal pressure they will ask? Internal pressure is, so P can be written as Pi minus P naught. P naught is atmospheric pressure. P naught plus 2T by R. This is the internal pressure in liquid drop. This is the excess pressure in liquid drop, 2T by R. For soap bubble, how much you will get means same, but it is having one surface 2T by R equal. It is having two surfaces in contact, therefore 4T by R. This is excess pressure. Now, what is the internal pressure means? Pi is equal to P naught plus 4T by R. So, this pressure is going to be inversely proportional to radius. If radius is bigger, pressure is going to be lesser. Next, how its surface area and volume can be related. How they will ask question means, so pressure radius of the soap bubble increases 8 times, R dash equal to 8 times of R. What happens to excess pressure they will ask. At the time we came to know soap bubble or liquid drop, pressure is inversely proportional to R because surface tension of that liquid is constant whenever you are making 8 times. So radius and pressure relation we came to know, but they gave here volume. Radius is, let us assume radius is going to be 8 times. This is very simple. It is going to be 8 times means it is going to be P by P dash is equal to R dash by R. So 8 R by R. 8 will be, sorry, R will be cancelled. Then P dash equal to P by 8. Within one step also you can write, if you practice well, the directly proportional, inversely proportional. If it is 8 times, it is P by 8. If it is R by 8 times, it is going to be 8P. That is very easy and simple. Now volume of the soap bubble or liquid drop is going to be 8 times of original volume they will give. So how you will get relation for radius and pressure? We came to know pressure and radius relation, but we came to know volume of this sphere. 4/3 pi r cube. Then volume is directly proportional to r cube. R is directly proportional to v power 1 by 3. That v power 1 by 3 we will substitute here. Correct? P is inversely proportional to v power 1 by 3. So then P1 by P2 is equal to V2 by V1 whole power 1 by 3. What is V2 they gave? V2 is going to be 8 V1. Substitute. So 8 V1 by V1 whole power 1 by 3. V1 V1 will be cancelled. 2 cube whole power 1 by 3. So P1 by P2 is 2. Therefore P2 is going to be P1 by 2 because it is inversely proportional. Like that they may ask volume is inversely proportional to 1 by 3 surface area. So what is the surface area and radius relation means? A equal to 4 pi r square. A is directly proportional to r square. R is directly proportional to a power 1 by 2. So here you will get a power 1 by 2. According to this, they are going to ask the questions. Next, so when they are combining, when they collapse each other, what is the excess pressure, resultant pressure or radius they will ask, we will see. Let us assume two soap bubbles are in contact of radius. One is R1, another one is going to be R2. Okay, whenever those are in contact, so what is the radius of this interface that where those are going to be combining? So radius of this interface. How we are going to calculate means P is equal to, so where pressure is going to be more. In this, P is equal to 40 by R1. In this, P is equal to 40 by R2. So R1 is bigger, P1 is going to be smaller. R2 is smaller, P2 is going to be more. Therefore, P2 minus P1 we will write. So radius of the interface, new interface is going to be R we are taking. Here 40 by R2 minus 40 by R1. So if 40 cancel, so 1 by R is equal to R1 R2, so R1 minus R2. So R is equal to R1 R2 by R1 minus R2. So radius of this interface is going to be this much. So another one they will ask, R1 is one soap bubble, inside another soap bubble is going to be there R2. Then what is the radius of this combination they are going to ask. At the time P is equal to, we will use P1 plus P2. So 40 by R. So effective radius of this combination 40 by R. 40 by R1 plus 40 by R2. So 1 by R is equal to 1 by R1 plus 1 by R. Then R is equal to R1 R2 by same equation, but here you are going to get plus. Next, they will ask two liquid drops. Two liquid drops combining in vacuum, they will ask. Two liquid drops combining in vacuum, what is the resultant radius of that? Both the liquid drops they are going to ask. R1, R. So in vacuum there is no pressure, therefore V is equal to V1 plus V2. So what is the volume of this effective drop means, liquid drop means 4T by R. 2T by R is equal to 2T by, sorry, volume we are writing, not pressure. What is the volume formula? 4 third pi R cube is equal to 4 third pi R1 cube plus 4 third pi R2 cube. Then 4 third pi will be cancelled. And what will be remaining? R cube equal to R1 cube plus R2. So R1 cube plus R2 cube whole power 1 by 3. 3 should not cancel. Okay. This is radius of that effective liquid drop. Okay. Now same they will ask in isothermal condition at vacuum or in vacuum. Two soap bubbles or liquid drops, whichever may be. Okay. So isothermal condition means temperature is going to be constant. At that time, how we will take equation means PV is equal to P1 V1 plus P2 V2. If it is soap bubble, P we will write 4T by R. Volume we will write 4 third pi R. P1 means 4T by R1, 4 third pi R1. P2 means 4T by R2, 4 third pi R2 cube. Isn't it? So 4t 4 pi will be cancelled. 4t 4 pi pi 3 will be cancelled. 1 r will be cancelled. Then what will be remaining? R square. Here r1 square plus r2 square. R is equal to root r1 square plus r2 square. All these formulas you should remember. If they ask in pressure, means atmospheric pressure is there. Here we will write P naught plus 4T by R. So like that you can remember, you will be getting very easily. Next, if liquid drop is outside, so liquid drop is outside, pressure we wrote, excess pressure we wrote 2T by R. If it is bubble or soap bubble, inside outside air will be there, inside air will be there, outside air will be there. At that time we wrote 4T by R. So relation between these two also you will get, here 2T by R, 4T by R. This is 2 times of this. Next, whenever you are filling water bottle sometimes or any vessel with liquid, if you are filling, so inside one air bubble will form. Inside one air bubble is going to be forming. So what is the pressure on this air bubble, they will ask. At the time, atmospheric pressure is P naught. This liquid is going to act, if it is at a depth h, P is equal to rho gh plus, so air only inside, therefore pressure is going to be inside here 2T by R. One surface is in touch with air, 2T by R plus rho gh plus P naught. This is the total pressure acting on that air bubble whenever it is at depth. If it is coming to surface, as it is, if it is coming to surface, at the time only P naught on surface, it is going to be P naught plus 2T by R whenever it is coming to surface, surrounded by liquid. So like that you have to take these pressures. So you may get one problem if they ask. Therefore try to practice. This is easy only to remember all these equations. Just you have to apply little bit mathematics. So I hope you people understood. So this is the end of fluids. Next we will do thermal properties of matter. Thank you.